This lesson is about square roots. We're going to estimate square roots, we're going to simplify, add, subtract, multiply, and divide. First thing we need to know is some vocabulary, and the radical symbol is that square root symbol, and the radicand is that number or expression that is in underneath the radical symbol. The radical symbol indicates only the positive square root, or what we call the principal square root. And when we want to indicate both the positive and negative, you use the plus minus sign. So if I'm just taking the square root of 25, then that is meant to mean just 5. If I'm taking the negative square root of 25, then I negate afterwards, which is negative 5. The plus minus in front of the square root, then our answer is plus or minus. Numbers such as 25 is a perfect square. Okay? Square roots of integers that are not perfect squares are called irrational numbers. You can estimate these values. For example, the square root of 5 lies between the square root of 4 and 9, so it lies between 2 and 3. Since it's close to 4, you can estimate it to be probably about 2.1 or 2.2. So we're going to estimate the square root of 34, and the perfect squares that it lies between is the square root of 25 and the square root of 36. So it's somewhere between those. And the square root of 25 is 5, the square root of 36 is 6. So it lies somewhere between 5 and 6. Since it rests closer to 6, you might want to estimate it to be about 5.8. So you can try that. 5.8 squared is 33.64. And since we're not quite to 36, you might want to try 5.9. And 5.9 squared is 34.81. And since that's a little too high, to 1, we would estimate it at to be 5.8. So I'd like you to pause the video and try to estimate the negative square root of 55 to the nearest tenth. So it would be negative 7.4. Okay, so we do have properties of square roots. The product property states that I can split a number into the product of 2 square roots, or I can multiply 2 square roots. So algebraically, square root of a times b or we could do the other way around. And the same thing with the quotient. If I'm doing square root of fraction, I can split it. Or I can combine so algebraically looks like this. Okay, so we can combine them under the square root or we can separate them. A square root, this is important, is in its simplest form when the radicand has no square root factors except 1 and there are no radicals in the denominator. Okay, so simplifying, and there's different ways you can do this. You could say that this is the same as negative square root of 25 times square root of 2, which would be negative 5 root 2. Or you do your prime factorization tree. For every 2, 1 comes outside. What stays inside are the singles. When I have a quotient, again, we can split it. Simplify the numerator, simplify the denominator. When I have a product, I can put them both under the square root. And when I have a quotient, I can put them both under the radical. Okay, so once again, pause the video and try these. And this one is wrong. It should be a square root of 20. Okay, when you have a denominator with a square root, it's called rationalizing the denominator, getting rid of that square root. Okay, so in order to do that, we must multiply by some number that we produce a perfect square under the radical. So in this first one, I'm going to multiply by the square root of 3 over 3. And you got to multiply both the numerator and the denominator by that. And you see then we end up with a nice number in the denominator. When you have something like this next one, you might want to simplify it first. Square root of 18 simplifies into 3 root 2, so that you multiply by the smallest number. You don't have to. You could have multiplied by the square root of 18. You just have larger numbers then that you have to work with. So once again, pause the video and try these. Make sure that you then simplify any fractions. And when we go to adding and subtracting, it's just like terms. We have like radicals that are those that are the same. And then you can add or subtract what is outside of them. So looking at the first example, I have like radicals. So I add just the 5 and the 3 and get 8 root 2. In the second one, I don't have like radicals, so I have to see if I can create like radicals. The square root of 12 is 4 times 3, so that's 2 root 3. Or do your prime factorization tree. And then you can just subtract what's in front of the radical. So you have 2 to try. Okay, and closing the lesson. Simplify 2 root 3 over the root of 6, that we have to rationalize the denominator. I can simplify square root of 18. So you end up with just the square root of 2. And that ends the lesson.